Hey everybody, in this episode we're going to take a look at random number generation. So in my PowerShell class, I kind of demonstrate how the command like get-random may not give you a good enough random number, particularly if you're doing anything with cryptography. So let's take a quick look at it. So we're going to go ahead and run the command get-random. Now, whenever I run get-random, we are going to get a different number. But one of the things we have to look out for is how is this number generated? You see, in cryptography, you need something called entropy, and that means disorder. And that has to be part of your input. It needs to be something that can't be recreated, because right now, I'm willing to bet that we might be able to recreate get-random's value. So let me show you something here. Using the seed parameter, we can override whatever the number is that starts this algorithm. This is the wall of entropy at CloudShare. Now what they did is they created this wall of lava lamps, and because they're constantly changing, they take a photograph whenever they need to create a new cryptographic key. They photograph this wall of lava lamps. Now you can walk in front of it, it's okay, that creates even more entropy. And the idea is, since this image will never be the same between two different images, it is virtually impossible for somebody to guess that starting value and put it in as the seed and generate the same random numbers that they're generating. Now with PowerShell 7, we do have a way to create more cryptographically secure random numbers. I'll show you that in just a minute. But I'm kind of taking a little bit of CloudShare's idea, and what I've got here is a function I call Get-PseudoRandomNumber generator. Now, what this does is it literally takes a screenshot of whatever you've got on the screen, and then it hashes it. When it hashes it, it creates a number that we're going to use to help make more of a random number. We're also going to use the internal clock of your machine, but not the full ticks value of it. Now, we have to make sure that this number comes out to be a 32-bit integer, because if it was any bigger than that, then of course this is going to fail. Using those two seed values added together with get-random is definitely going to produce a random number. So in other words, in order for somebody to replicate this, not only do they need to do it at the exact time you do, but they also need to have your screen, an image of your screen. So let's run this command and see how it works. So I'm going to go ahead and put this function into memory. And now whenever I need it, I just run Get-PseudoRandomNumber, takes a screenshot, does the calculations, and now I get a number that, again, the only way somebody is going to be able to replicate this is if they know exactly when I executed it and also had an exact copy of what I was seeing on my screen at the time. Here's the help file for the commandlet Get-SecureRandom, and this actually uses the random number generate class to help produce a true random number, or at least it generates a cryptographically secure random number. And you use it just like you would with get-random. And again, you can produce minimum and maximum values. If you feed it a collection of objects, it'll randomly choose one of those objects. So again, if you need cryptographically secure random numbers, go to PowerShell 7.4. That's the minimum version of PowerShell that has this capability. And you can use the commandlet Get-SecureRandom. Thank you for watching. Click subscribe. See y'all later.